Welcome to Engineering Concepts. Today we're going to discuss about compressor and their types. Compressor. A compressor is a mechanical device that increases the pressure of a gas by reducing its volume. Compressors are similar to pumps, both increase the pressure of a fluid and both can transport the fluid through a pipe. As gases are compressible, the compressor also reduces the volume of a gas. Though air compressor is not directly connected to the pneumatic system, it plays a vital role in the overall system performance. Various types of air compressors are used in the industry. But the most popular type of compressor in the industries is positive displacement compressor. The air receiver is also a very important component. For uninterrupted supply of compressed air, receiver with optimum size should be selected. As we know that the Earth's atmosphere is a mixture of gases such as nitrogen, oxygen, argon, carbon dioxide, helium, krypton, hydrogen, ozone, and water vapor, etc., in different proportions. Because of the presence of the water vapor, condensation of moisture should be given due importance while one selects and installs a compressor plant. Some compressors have receivers attached together, and some doesn't. Compressors after working continuously for several hours get heated up. That is why compressors usually have cooling systems. Compressor plant should be located at places with good air ventilation. Classification of air compressors. Compressors can be classified in two ways. They are 1. According to the pressure delivered, and 2. The design and principle of operation. 1. Compressors according to the pressure delivered. Low pressure air compressors, LPAC, which have a discharge pressure of 150 pounds per square inch or again less. Medium pressure compressors which have a discharge pressure between 150 to 1000 pounds per square inch. High pressure air compressors, HPACs, which have a discharge pressure above 1000 pounds per square inch. 2. Compressors according to the design and principle of operation. Single-stage reciprocating compressor. Two-stage reciprocating compressor. Compound compressor. Rotary-Screw Compressor. Rotary Vane Compressor. Scroll Compressor. Turbo Compressor and Centrifugal Compressor. 1. Single-stage reciprocating compressor. In single-stage reciprocating air compressor, the entire compression is carried out in a single cylinder. The opening and closing of a simple check valve depends upon the difference in pressure. If mechanically operated valves are used for suction and discharge, then their functioning is controlled by cams, as shown in this animation. When piston starts moving downwards, the pressure inside the cylinder falls below atmospheric pressure and suction valve opens. The air is drawn into the cylinder through a suction filter element. This operation is known as suction stroke. When the piston moves upwards, compresses the air in cylinder and inlet valve closes when the pressure reaches atmospheric pressure. Further compression follows as the piston moves towards the top of its stroke, until when the pressure in the cylinder exceeds that in the air storage. This is compression stroke of a compressor. At the end of the stroke, discharge valve opens and air is delivered to air storage tank. Two-stage reciprocating compressor. With two-stage air compressors, the air is compressed in two stages. In between the stages, the air is cooled. Stage 1. Air is compressed to medium level, which is the big cylinder. It moves a high volume of air, but at a low pressure. Now the air is cooled back to a much lower level, making the compressor more efficient and reducing stress. Stage 2. The air is compressed further to the end pressure, which is the small cylinder. It moves a lower volume of air, but at a higher pressure. On some models, you can clearly see the two stages, while on others, the low pressure and the high pressure cylinders are cast in one block, making it look like a single stage compressor. 3. Compound compressor. In compound compression, the work of compression is divided into 2 or more stages. In two-stage compression, air is compressed in the low-pressure cylinder to a certain point, then forced into an intercooler where it is cooled to approximate its original temperature, then passes into the high-pressure cylinder, in which it is compressed to the final or delivery pressure. 4. Rotary screw compressor. A rotary screw compressor uses a rotary-type positive displacement mechanism. They are commonly used to replace piston compressors, where large volumes of high-pressure air are needed, either for large industrial applications or to operate high-power air tools such as jackhammers and impact wrenches. For smaller rotor sizes, the inherent leakage in the rotors becomes much more significant, leading to this type of mechanism being unsuitable for small air compressors. The gas compression process of a rotary screw is a continuous sweeping motion, so there is very little pulsation or surging of flow, as occurs with piston compressors. This also allows screw compressors to be significantly quieter and produce much less vibration than piston compressors, even at large sizes, and produces some benefits in efficiency. 5. Rotary vane compressor. You have a cylindrical rotor inside of a housing, and this rotor has slots where the vanes are. The vanes can slide in and out. The rotor is set eccentrically, off-center, in the housing so that on one side it almost touches. As the rotor spins, the vanes are thrown out by centrifugal force, until they touch the housing. If the pump is oil lubricated, there will be a thin film of oil in between the vane and housing. As air enters through the inlet, it's trapped between the vanes. As the rotor turns, the volume of the trapped air is gradually reduced. The reduction in volume raises the pressure. Six. Scroll compressor. A scroll compressor uses two interleaving scrolls to compress gases. The vane geometry is Archimedean spiral. Often, one of the scrolls is fixed, while the other orbits eccentrically without rotating, thereby trapping and pumping or compressing pockets of fluid between the scrolls. Another method for producing the compression motion is co-rotating the scrolls, in synchronous motion, but with offset centers of rotation. The relative motion is the same as if one were orbiting. Leaks from axial gaps are prevented by the use of spiral-shaped tip seals, placed into grooves on the tips of both spirals. These tip seals also help lower the friction and can be replaced when worn down. Some compressors use the pressurized discharge gas to push both scrolls together, eliminating the need for tip seals. They have casings filled with lubricant to prevent abrasion of the exterior of the pump tube and to aid in the dissipation of heat, and use reinforced tubes, often called hoses. This class of pump is often called a hose pumper. Since there are no moving parts in contact with the fluid, peristaltic pumps are inexpensive to manufacture. Their lack of valves, seals and glands makes them comparatively inexpensive to maintain, and the hose or tube is a low-cost maintenance item compared to other pump types. Seven, turbo compressor. Thermal turbo compressors are turbo machines which concentrate a compressible gas with the help of dynamic principles. In doing so, the gas continuously enters the rotating impeller. Mechanical shaft power is transferred to the fluid with the help of the blades and resulting in a significant pressure and temperature increase. The remaining kinetic flow energy is afterwards mostly converted into pressure in the diffuser. The compressed gas is then either collected in a volute or transferred to a second compressor stage with the help of a return channel. In figures, the components of a one-stage, centrifugal turbo compressor and the close-up of an impeller including blades are shown. 8. Centrifugal compressor. Centrifugal compressors, sometimes called radial compressors, are a subclass of dynamic axisymmetric work-absorbing turbomachinery. They achieve a pressure rise by adding kinetic energy or velocity to a continuous flow of fluid through the rotor or impeller. This kinetic energy is then converted to an increase in potential energy or static pressure by slowing the flow through a diffuser. The pressure rise in the impeller is in most cases almost equal to the rise in the diffuser. Thanks for watching. Please subscribe, like, and share.